Okay. So today I'd like to talk about the new features in OpenResty and what is coming soon in this year. Some of you have already noted that we are rolling out the Stream Lua module. It's already open sourced and it's on GitHub. So unlike the existing NGINX HTTP Lua module, the Stream module allows you to take advantage of the Stream subsystem of NGINX, which means that you can speak up to TCP protocols as you wish, not just HTTP. And so basically, I cloned a lot of code from the HTTP Lua module. I don't like it, but there's a plan to introduce a NGINX Matter Lua module that can be shared among all the different subsystems Lua module variants. For example, we have this simple configuration, which where we define a TCP server listened on 1, 2, 3, 4, and then we just output a hello Lua line to the client. So testing this only requires a telnet, no HTTP involved here. And here's a more complicated example where we set up an SSL TCP server. And also we make use of the downstream code socket to read data from the wire sent by the client. So here we just read a single line, and if it's a sounder, we output flash. So this is the World War II's the passcode used by the United States Army. And OpenResty's core component, NGINX Lua, has a lot of directives that allows you to inject Lua code at various different phases. So it doesn't hurt to add even more. Just recently we added SSL certificate by Lua, which allows you to use Lua to control downstream SSL handshake process. And we also provide Lua modules like NGINX.SSL and NGINX.OCSP, so that you have a lot of Lua APIs to handle the SSL certificates, private keys, OCSP stapling, and various other kind of things. So here's a minimal example. We use the SSL certificate by Lua block to inject this piece of Lua code, where we first clear our default certificates and private keys, and then we set our own certificate just for this very SSL session. And then we can set the private key accordingly. So this is a scheme used by Cloudflare's SSL gateway for more than 1 year in production. So basically we have many edge servers serving a huge amount of client traffic, and different servers may serve different kinds of websites, but there are a lot of websites possible. So it's unreasonable to eagerly load all the certificates or private keys into every single node. It just doesn't work because there's just so many certificates and so many possibilities. So we do lazy loading here. We just lazily load SSL certificates and private keys only on demand. And we cache things when the traffic keeps going. And if the traffic goes, the loaded certificates and private keys will also go away according to LRU. So one thing to note here is that the SSL traffic is not even across all the Cloudflare networks. So some server may be busy processing a set of sites, and some nodes may be busy processing another set. So we can take advantage of that. So the next features that are going to get open sourced is the SSL session blah blah by Lua directives, with which we can effectively share the SSL session among different servers. Right now, NGINX just shares the SSL session ID cache on a server basis. So with these directives, you can, employ a distributed caching system, like a distributed memcached cluster to share all the SSL session IDs. Nowadays, TLS provides SSL session tickets, which is states held by the clients, which doesn't require server-side state saving. But for older web browsers, SSL session IDs are still the only choice. Okay, so why should we bother sharing or caching the SSL sessions? Because SSL handshakes are so expensive. It's so important to resume SSL sessions without doing the full handshakes. It's very important for HTTPS optimizations. And also we introduced the balancer by Lua thing. It's a big feature that we can take advantage to write highly dynamic Lua balancers for existing NGINX upstream modules like proxy, like fastCGI, like UWSGI, and something like that. Basically, we define a generic upstream block, say my backend, and then within the balancer by Lua block, we dynamically set the current backend peer to try or retry. And we also can configure the standard keep alive directive to enable the backend connection pool. So one nice thing about this is that we have highly dynamic backend dispatching, because here we can dispatch every individual request to many different websites without defining too many upstream blocks or too many static peers. So imagine that we can load the IP address and the port number from some remote services like Memcached or Kyoto Tycoon and cache them in shared memory and or Lua VM level caches. And we can use standard proxy module to just use our dynamic upstream as usual. So NGINX semaphore is also a big feature introduced just recently. And this is for synchronizing live threads in the OpenResty context, very similar to the old school semaphore API. So basically, we require the semaphore module, and we initiate a semaphore instance via a new method. And some producers can call post on this object to release resources. And some consumers, possibly run in some other request handlers, can wait on the semaphore asking for resources. If there's no readily available resources, just wait there, non-blockingly. But this call will never return until the timeout threshold is reached. Here it's just 3 seconds. So like good old school semaphores, there is a possibility of deadlocks. So it's important to always introduce the timeout here. So even there's a deadlock, you won't hang there forever. And before semaphores are introduced, people are relying on sleeping, periodically sleeping and checking. So it's like a polling thing, right? So which is very inefficient. And semaphore can scale much better than a lot of sleep operations. And we have lists and queues in Lua shared dictionaries. This is still a pull request, not in the core yet, but we are reviewing this. Basically, we are introducing the list-typed values to the existing shared memory dictionaries. For example, we can just grab the animals shared dict, and then we can do the Redis-style rpush operation to insert some data value into a queue named under the key docs, and we can push more, and then we pop from the beginning. So this is like a queue. We can also use it like a stack if you wish. So basically, we are mimicking the Redis API style. And with the shared memory lists and NGX semaphores, we can achieve C2000K in a single node. And some of our developers performed this experiment for their real push systems. But you still need some very careful configurations, like reducing the request pool of the NGX to reduce per request memory usage. And also you need to speed up the Lua-JIT garbage collectors pace so that you can collect garbage more quickly than the default. Lamplate is another toy I created lately. And it's essentially a compiler that can compile TD2 templates into standalone Lua code for OpenResty. Basically, we have, so TD2 is a popular templating language. It's a DSL in the pro world. I think some of you might be PHP or Python programmers. You may have your own favorite templating languages, but my favorite is TD2. So basically, you use a DSL to code up a template, and there's some built-in filters like HTML so that you are safe from JS injection attacks. And then we use a command line utility, Lamplate, to compile one or more TD2 template files into a standalone Lua module file. And then in the NGX configuration file, we just use the content by Lua block and load that module via require and prepare some data to feed into the compiled template. So the template file name here is just used as a key, which doesn't involve any file accesses. So here's an example. Using curl, we get an HTML. Okay, so there was a compiler called Gemplate, which can compile TT2 templates into browser-side JavaScript codes, which means that the single set of template files can be reused both on the server side and the client side, which is pretty cool. I know that some of the template engines use, like Lua in the template file directly, which makes such template sharing impossible. So I really like DSLs. Okay, so this is a bit old, actually. So last October or November, I worked on the official Windows binary to make some Windows users happy. I've noted that some people prefer working on their native systems, even though they will eventually deploy on a Linux box. So some people prefer Mac OS X, some prefer Windows, and so here it is. We have so many LuaResty libraries. So some of which are standard ones, some are contributed by the community. So it's important for us to have an official package management toolchain website. So this is of a high priority. And the LuaRocks guys want collaborations, and I agree. So the current plan is to allocate a separate zone on the existing LuaRocks website. Here, resty.luarocks.com. And I insist in using a shorter name than LuaRocks. LuaRocks are way too long, and OPM is good, 3 letters. Shouldn't be shorter, and we can install. And another thing that I really insist on is the prefix of the library names, so just like GitHub's, so that I don't want people fighting for namespaces, and I encourage people fork things when the existing thing breaks, which is a feature missing in the existing LuaRocks. I've already sent my feature request to LuaRocks developers. And OpenResty standard libraries will also be distributed under the OpenResty namespace. So we will have a one-to-one mapping between OpenResty, Lua rocks, and GitHub, so that people don't have to fight for IDs either. Okay, so this thing is huge. We are going to have the OpenResty Edge platform. So the current OpenResty will serve as a virtual machine, which is a core, and the Lua language you guys are currently using will be just the machine code. You will still be able to use Lua as you wish, but we provide more options, high-level options. Basically, we will introduce a set of DSLs, domain-specific languages, so that we can declare our intentions for web gateways and web applications more easily. And for example, here's a very simple example of an Edge program. And we can specify a set of rules. So each rule has a bunch of conditions and a bunch of actions connected by this arrow symbol. And in the conditions, we have predicates like UI, like UI arg, or UI prefix. And in actions, we have common operations, or even very handy primitives for handling cookies, UIs, request bodies, response bodies even. And we will have first order citizens like regular expressions and even wildcards or string literals. And we have scatter variables so that you can alias an expression to a variable and reference it later in an action. And one beautiful thing about a DSL is that the compiler can do optimizations on a much higher level than before. And we can do inter-rule optimizations to combine conditions so that we can only scan the URI string for every request for only once, instead of 100 rules scanning for 100 times, which is a waste of CPU time. And such patterns can be compiled into a whole chorus 6 state machine, or even a more general DFA. And also, there will be a scheduler to schedule the rules, maybe run the rules out of order, but preserve the inherent semantics. Okay, so this is a big thing. And we can not only use it to write routing rules or filtering rules, but also use it to create some web application firewalls. So we have noted that the Edge optimizing compiler can generate highly efficient Lua code. There's a lot of gotchas when writing high-performance Lua code. It's so easy to write slow Lua code, and highly optimized handwritten Lua code is not really readable, as you can tell. So it's better to be done by the machine, by a compiler, which can do all the optimizations, all the small things automatically. And it will also automatically integrate various different kinds of regular expression engines and use different ones for different tasks. For example, PCRE-JIT is very good for simple registers because it's a backtracking engine, but it runs so fast. sregx DFA is comparably fast. It's just that the DFA uses more memory. And one nice feature about sregx DFA is that it can do streaming processing, which means that for huge response bodies, we do not have to buffer the whole stream before we get anything interesting. So Intel HyperScan also supports streaming, though it was just open source like a few months ago. But the downside is that Intel HyperScan is a huge library. It's so big. I mean, the compiled binary components. But it has its use. Its strength is processing many registers at the same time. So which should be a good fit for web, but we haven't really tried yet. And Google Read 2 is an automator-based regex engine. is quite stable. It doesn't suffer from the backtracking pathological cases, but re2 is consistently slow for good cases. It's like 1 time slower as compared to PCRE JIT in our Cloudflare's Lua WAF, for example. We will have an OpenResty WAF platform. It will be completely different from Cloudflare's Lua WAF, though they share the same basic architecture because they both run on the OpenResty platform. And hopefully we can do much better in the open source version, but let's wait and see. So we know that most security community has accumulated quite some rules, filtering rules, so it will be awesome if we can reuse them. And the web platform will have a translator that can convert most security configuration files into OpenResty edge code. It's a DSL, as we've seen earlier. Okay, so there will also be a relational world DSL called ORSQL. It has its origin when I was developing the data analytics platform for Taobao. And I used to create a DSL called LDSQL for that product. And that data analytics platform has, like 2 million active users every day. And it has a huge amount of data to, analyze online. And I learned the lesson, so I want to do it in the open source world in a more generic setting. So I proposed the notion of relational mapping. I know that ORM, object relational mapping, is very popular, but I really hate that. And I think that relational languages SQL is really a nice formalism to use when coding up web applications or web analytics platforms applications. So here's a very simplistic example that we basically make the SQL parameterized. We can declare, typed variables and then reference them in arbitrary SQL queries, and we'll generate the Lua concatenation code, taking special care of the SQL injection and quoting and everything, so that it can ensure that each variable is used in the right context. For example, if we declare the database as a symbol, then it cannot be used as a value. So it will be a type checker and type inference engine in the ORSQL compiler. And also there will be an internal in-memory database that you can run the queries directly inside Nginx, which is very useful when you have various different kinds of data sources and you want to aggregate the results from different data sources in memory. And so it could be very cool. And finally, we will have the Y language. And so why my first letter, the first letter of my first name. And also this language aims to solve the problems for questions starting with why. So it's for debugging purposes. Basically, the Y source language will be very similar to, for example, C, when you are tracing a C applications. And we use Y language to write very complicated debugging tools, and the Y compiler will generate runnable code for various different kinds of debugging platforms. For example, SystemTab is a very powerful dynamic tracing framework in Linux, developed by Red Hat. We've been using SystemTab for online profiling and online troubleshooting in Cloudflare's global network for years already. And the SystemTab developers are very friendly, and they are very responsive. So SystemTab is for live systems, which involves very low overhead, but it can help you find very deep answers, or very deep problems very quickly without reloading the service or isolating the service alive. So GDB is best for debugging dead programs. dead processes like a core dump. And so GDB provides Python, the Python language, to code up very complicated tools. So I hope that the Y compiler can automatically generate the Python code as well. And so is LLDB, which has an incompatible Python API, unfortunately. So in the past 2 years or so, I've been writing similar debugging tools for multiple times over and over again, because these platforms accept different languages, and I really hate that, and it requires extra debugging and extra troubleshooting. So ideally I can just write this debugging tool once in the C-like language, because we are usually just debugging C programs, and then the compiler can just generate all the things. Linux eBPF is a new thing, relatively new thing. So BPF is a virtual machine or dynamic compiler in the kernel for net filter rules. And the eBPF is an extended BPF which can support highly complicated debugging routines directly inside the kernel. So it's like a VM in the kernel. We could possibly generate the eBPF bytecode directly without using systemtab. But the eBPF thing is quite new, and it still needs time to materialize. Any questions? Sorry. Yeah. Yeah, sure. In the next few weeks. Yeah. Okay. So one more thing about the SSL session thing, we requires patches in the OpenSSL library. Yeah, because it doesn't have an API to do non-blocking processing in that handshake phase. Yes. Okay. Any other questions? Okay. So,
DSL, what kind of tools are you using for sending?
Oh.
Use a typical,
okay, so DSLs are actually fun to implement, to be honest. And I'm currently using Perl to write the compilers. And there's plans to port the compilers to C++ or Lua in the future. But Perl is my mother tongue in the computing world, so it's very easy to code up complicated text processing things in Perl. Yeah, sure. Any other questions? Okay, so what time is it? Oh, good. Well, so still within 6:30. Okay, thanks for coming. We will publish the recorded video on the website, the Meetup website and the OpenResty official website. Yeah, hopefully we can meet again, like after 2 months or so. Thanks for coming.